Position time graphs are a convenient way to represent and interpret motion. So in a position time graph, the position is on the y-axis and time is on the x-axis. All motion graphs are always drawn with time on the x-axis. So x represents the position and t represents the time. So if I have a position graph in which my plot turns out to be, let us say, a horizontal line, let's label this as A. What type of motion does A represent? So as you can see, the position of the object in A does not change as time increases. So A represents rest. This means that the object is not moving at all. What if the position time graph for my object turns out to be a diagonal line like this? You can clearly see that for this object, which starts at 0, every second its position climbs up by exactly 1 unit. So that means this object covers equal distances in equal intervals of time and always moving in the forward direction. So B represents constant positive velocity. The positive sign indicates that it is moving in the forward direction. So if I want C to represent constant negative velocity, how do you think the plot would look like? How will you draw constant negative velocity on the graph? If you said a line that is sloping downwards, you are right. So if you have a line that is sloping downwards, it represents an object starting at a higher position and its position decreases as time increases. So it's moving towards the origin, which means it has a constant velocity but moving in the negative direction. So how would we represent an object which is speeding up or slowing down? For example, if this is how my graph looks, what does this curve represent? Let's label it as D. So D represents an object which during the first time interval, let us say this is a second, then in the first second it covers this much distance. In the next second it covers a little bit more, and in the next second a little bit more, and then in this second you can clearly see it covers much more distance. So the distance covered in every second keeps increasing with time. So this represents an object that is speeding up, or this represents acceleration. We can summarize all of this by a single concept, that the slope in a position time graph is, we know that slope always stands for rise over run, and we know that this rise here represents the change in position, the run here represents the time. So the slope of a position time graph represents change in position over change in time, which we know is velocity. So the slope in a position time graph represents the velocity. So a positive slope means positive velocity, negative slope means negative velocity. A curve means the slope changes, that means the velocity is changing. A horizontal line is no slope, no velocity. So let us see if we can use this information and interpret a position time graph. So here is a position time graph. As you can see that the object is not having the same type of motion all the 9 seconds. So the first 2 seconds, it is moving at a constant speed in the positive direction. And what is it doing from 2 to 4 seconds? Yes, it is moving in the reverse direction because the slope is negative, but again going at a constant speed. 4 to 6, no slope, that means it is not moving at all. 6 to 9, positive slope, that means again it is moving in the forward direction with a positive velocity. Let's calculate the speed of the object in one of the time intervals. Let's say from 0 to 2 seconds, let's calculate the speed. So we know that speed or velocity is going to be represented by the slope. So let me draw this triangle. So the rise represents the change in position, which it started at 0 meters and at the end of the 2-second interval it is at 3 meters. So delta x, our change in position, is 3 minus 0, which is 3 meters. The time interval in which this change in position happened is 0 to 2, so it is 2 seconds. So we know that the slope is the velocity, which is delta x over delta t. So it is going to be 3 meters over 2 seconds, which is 1.5 meters per second. What about the speed in between 2 and 4 seconds? If we want to do the speed between 2 and 4 seconds, let's construct the slope triangle for the 2 to 4 second interval. So we know that a straight line has the same slope everywhere, so you can take a part of this or you can take the whole triangle. We want to take something that is easily readable, so that is why I'm going to take the entire time interval. So this is my change in position, which is, this is going to be negative 0.5 because 2 units make 1 meter, so this is going to be negative 0.5. So it started at 3 meters and ended up at negative 0.5, so delta x is negative 0.5 minus 3, which is minus 3.5. Delta t is 2 to 4 seconds, which is 2 seconds. So our velocity is negative 3.5 meters over 2 seconds, which will be 1.75 negative meters per second. So if you're asked the velocity, you would indicate it with the sign because velocity is a vector and you have to indicate the direction. If you want speed, you will always report it as the absolute value. So then speed will just be 1.75 meters per second. Okay. This way you can determine the slope of the line to give the speed at any instant of. Let's look at a couple more things. What if I want to calculate the displacement in the first 6 seconds? So displacement we know is change in position, final minus initial position. At 0 seconds, the position is 0 meters, and at 6 seconds, the position is going to be negative 0.5 meters. So my final position is negative 0.5 minus my initial position is 0, so therefore it is going to be negative 0.5 meters. So you can always find out the displacement in any given time interval as a change in position. What if I wanted to calculate the distance traveled? The distance traveled can be calculated easily by using the data from the graph. So let's say we want to calculate the distance traveled from 0 to 9 seconds. Notice it started at 0 and at the end of 9 seconds it came back to the origin. That means the displacement in 9 seconds will be 0. However, if you want to solve for the distance, that will not be 0 because distance is just the path length. So we know that 0 to 2 seconds it traveled 3 meters. And then 2 to 4 seconds, it traveled from 3 to 0.5, so 3.5 meters. 4 to 6, it was not moving at all. And 6 to 9, it went from negative 0.5 to 0, so that means it traveled another 0.5 meters. So the total distance traveled will be 3 plus 3.5 plus 0.5, which will be 7 meters. So you could use the position time graph to conveniently interpret data. It's much more convenient than reading lines and lines of position time data. So it's an easy interpretation. And to summarize, if you remember that slope in a position time graph represents what? Velocity. Then you will be able to tackle all problems on position time graphs.